Assalamualaikum, can you hear me?
Yes, Doctor.
Right.
Yes.
Waalaikumsalam.
Hello. Waalaikumsalam. Yes, I can hear you.
Nggak usah.
Ada
orang lain yang bisa jawab.
Off microphone, please. Okay, we begin with example 8, correct, Example 8. After we discuss the example 7, for a unity feedback system that has the forward transfer function as given here, okay, where the open loop poles, open loop zeros is -2, and open loop poles is you have to press the calculator, okay, to find the value of open loop zeros. I think which is the value is can somebody press the calculator, please? What is the roots for s square minus 4s plus 13? 2 plus minus j3, 2 plus minus j3. Okay. So that is the open loop poles. So we have 2 open loop poles and 1 open loop zeros. This is very important to recognize the number of open loop zeros and open loop poles and the value as well by looking at GS. Okay. So you must have the ability to recognize these informations as I written in the read text. You are required, the rule locus is given, is in the next slide. Find the imaginary axis crossing, and then find the gain K at the J omega axis crossing, and find the break-in point. Find the angle of departure from the complex poles and verify using MATLAB. So the plot is given here, okay, full scale, which is as shown in the slides number 76, okay. So this is the J omega crossing, okay, of the root locus, okay. So the value is plus minus J 4.58, plus minus J 4.58. Can you see, guys?
Yes, okay.
And the gain K, which is K critical, is equal to K 3.99 as written in the MATLAB. But in the test and in the exam, you have to calculate the gain K, okay? And then for the break-in point, which is located here, okay? So the value is -7, okay? And the gain is 18, okay? So let's see how we calculate the gain K at the J omega crossing by using the whiteboard here. Can you see my whiteboard, guys?
Yes, Doctor.
Okay.
Yes, doctor.
So the hilang pula. Wait. Saya goes to here. Okay, here. So again, that is we use the K equal to K critical. Okay, why we call it K critical? Because it's the gain value that is in between stable and unstable on the imaginary axis. That's why the K over there, we call it as a K critical. So S square minus 4S plus 13 magnitude over S plus 2. And then S is the point where the J omega crossing, where the root locus cross the J omega, which is we read from the board just now. It is plus minus J 4.58. Okay, so we choose one point only, 4.58. Then we use this S value, we insert inside S. Okay, then you will get K is equal to 3.99. Okay, or 4. So that is the K critical, guys. Okay, and then break-in point, which is we read from the root locus, which is minus 7. Okay, minus 7, which is S. Then to find the gain at break-in point is by replace the S value okay. So we replace S is equal to minus 7. We insert inside this formula. Okay, the break-in point. So the value is 18. Okay, 18. Cepat. Huh? Okay. Okay, guys.
Okay, Doctor.
Right. So we already read this one. We already find the gain K. We already find the break-in point, and the third one is to find the departure angle. Okay. So departure angle is somewhere here. Okay. Okay. Departure angle due to the complex conjugate poles. Okay. Which is 2 plus minus J3. Okay. So to find the gain K by calculations, okay, first we construct the Roth-Lewis criteria. This is the closed loop transfer function. Okay. And the characteristic equation is S square plus K minus 4 over S plus 2K plus 13 equal to 0. Okay. So this we call as characteristic equations. So we plug in inside the Roth-Lewis S square, S1, and S0. 1, K minus 4, 2K plus 13, 0. Then we simplify using the determinant formula as shown in the previous slide. Okay. So from the first column, okay, we see that K minus 4 equal greater than 0. Okay, so first column of Roth-Lewis, K minus 4 greater than 0, K greater than 4. Okay, So we choose k equal to 4, which is will give you critical gain, which is here. Then we insert inside the even equation, which is s squared 2k plus 13 equal to 0. Then we get s squared plus 21. S squared 2k plus 13 equal to 0. So k is equal to k equal to 4. Okay, and then we insert inside. So we'll give you s squared plus 21 equal to 0 minus 21 square root 21, which is plus minus 4.58. So that's why what we read from the graph, which is plus minus j 4.58. When we verified using calculation, analytical calculation, we get the same answer. Okay, as shown here. So for the break-in point is by calculations. So this is the open loop transfer function. Okay, by assuming k equal to 1. So we do the calculations. You assume this one is u, this one is v. So it is v du, u dv, and v squared equal to 0. Then simplified. So you get the quadratic equations. Then we have to choose either -7 or +3. So by looking at the plot, the location of the break-in point at there, which is -7. So we choose -7. Okay, we ignore +3 because +3 is not the breakpoint. Okay, so you have to comment there. We choose -7 due to the break-in point at the root locus given is at -7. Then calculate the gain k there. This one I show already in the previous slide. So this one is by using Pythagoras theorem. So I don't advise you to use this, okay? Because it takes more time. You use the one that I show in the whiteboard, which is this one. This one, okay? Use this one to calculate the break-in point. Then angle of departure, as I show you before. So we have we put any point near to the complex conjugate pole. Let's say it's epsilon. Okay, and then we use the angle criteria, which is arctangent 3, 4 from the triangle. Okay, minus 90 degrees minus theta equal to 180 degrees. Okay, so solving for it. So the departure angle is -233.1. Okay, which is on this side. This is a plus minus, 233.1 and 360 minus 233.1. And for the crossing, as shown here, is which is over here. Okay, already shown. Break-in point already shown by observations and by calculations. Okay, so it is the same. Next example, example 9. You are given a model, GS, open loop transfer function. So we try to recognize first what is the open loop zero. Open loop zero, not available. Okay, but open loop poles, we have 1, 2, 3. Open loop poles, which is 0, -1, and -4. Okay, the root locus is given. Okay, and you have to verify your calculations and then find gain K so that the system operate at the damping ratio zeta equal to 0.5 and compare your value. Okay, so when we said that theta is zeta is 0.5, you must understand the concept of the theta. Okay, so first we plot. This is example 9. This is the real axis. This is the d omega axis. And the plot is s plus 1, s plus 4. So s plus 1, s plus 4. So 0, open loop 0, -1, and minus 4. Okay, guys? Then we have the locus, which is here. Okay, ended at infinity. Then this one also ended at infinity. Okay, very straightforward. So what I'm trying to say is the zeta is equal to 0.5, guys. So 0.5. So you must remember the formula cos theta equal to zeta. Zeta is equal to cos inverse theta. Silap. Sorry. Theta is equal to inverse cos zeta. So inverse cos 0.5, theta is equal to what? Kyron. Inverse cos 0.5.
Secret 60.
60 what? 60 rupiah, 60 ringgit, 60 cents.
Kali.
Nah,
Eh.
60 what?
Enggak.
Degree.
Degree.
Degree, ayo. 60 degrees,
60 degree.
So we use a protector. Use protector. Repeat. Protector.
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 Use protector.
Protector. Something like that. Theta. Okay. Theta is equal to 60 degrees. So this is the zeta 0.5, guys. And our concern is this point. This point. Okay. So this point, we call it as a dominant poles. Repeat.
Dominant pole. Dominant pole.
Dominant pole. Right. So this is it. 0.5 cos theta equal to zeta. So theta is inverse cos zeta, inverse cos 0.5, 60 degrees. Then draw the line. Okay. The intersections between the straight line of zeta and root locus yields the dominant poles. This one. Okay. This is using a protector on the real roller coaster. So you have to to prepare. You have to prepare the what do you call it? Protector in your pencil case. Okay. If you don't have any, you have to go and buy one. If you forgot to buy and you forgot to bring, you have to borrow from your friends on the right or on the left hand side of your friends. Okay. Firdaus, Muhammad Firdaus,
Saya
what is the dominant pole's value in this case?
0.6.
Tak faham lah tu. Tak faham, salah. Aulia Sadikin, what is the dominant poles in this slide 86?
Negative 0.396
Mhm.
plus 0.687 imaginary.
Imagine J lah. J
J.
0.687. So that is the dominant pole. Okay. What is the gain value at the dominant poles? Akmal Hakimi.
Gain value 2.66. Dominant poles negative 0.396 plus J 0.987.
Haikal, what is the value of undamped natural frequency in this figure?
0.793.
Unit?
Radian per second.
Huh?
Radian per second.
Radian per second. So actually the length length length, the length from origin 0 to dominant poles is omega n. Okay, the length from the origin to the dominant poles is also omega n, which is 0.793. Amar K,
Ni saya
what is the value of overshoot percentage in this case?
16.4%.
What is the formula for overshoot in zeta terms? Akmal? Ammar?
I don't know, Doctor.
Oh. So this is the formula. Okay. Hello guys.
Yes, Doctor.
Yes,
Hello.
noted.
Noted. Okay. I wrote again. Overshoot exponent multiply 100. Okay. OS is equal to 1 minus 100% gone. Okay. 100% gone. So how to find zeta? If overshoot is 16.4. Using the formula. Marina Jaslin. Tak datang. Karina Jaslin.
Yeah.
Ada pun. How to find zeta if overshoot percentage is 16.4 by using the formula shown?
Substitute the 16.4 into the OS and then calculate.
This one substitute here. So 0.164 exponent like this. This is what you mean?
Yeah.
Okay. Yi King. Yi King.
Yes, doctor.
How to solve this? How to simplify this to find zeta using what?
Move the ln to side 0.164.
0.164. This is what you mean?
Yes.
Okay. So ln E is equal to C chop
1.
E,
1.
and ln 0.164. Help me.
Negative.
1.808.
1 negative.
0.808.
Okay. So minus zeta minus pi zeta. Okay, simplified. So you simplify, so you will get zeta which is equal to 0.6. Okay, all right. So this is the dominant pole, and to find gain K here, okay, you can use theorem Pythagoras or simply using the gain formula. Yong-Seng,
Yes.
what is the formula for gain K? Magnitude
Magnitude magnitude S plus 1, magnitude S plus 4.
and replace with the value of dominant.
Dominant poles.
Yeah. Okay. And the value is, the answer is 2.66. Okay. This one no need lah because it's more complicated. So using this one, you just take the dominant pole, put inside the formula using calculator to calculate the magnitude, so you will get directly the answer 2.66. Okay. All my students follow this one, this method. Okay. Guys.
Okay.
Okay.
Yes.
Okay.
Right. So this is the verification. Verification. And how to draw damping ratio line via MATLAB is we using this program at the double prompt STF apostrophe S apostrophe. Then write the transfer function. Then write the root locus G. Then zeta is 0.5. Okay. So zeta 0.5. Just now I mentioned 0.6. Sorry, zeta. This one is wrong. 0.5. Sorry. So everybody is sleeping. Z equal to 0.5, then use this command as grid. Zeta, comma, 0. So why 0 here? Wen Hui. Why 0 there? Why not 1, 2, 3? Wen Hui? Tak datang. Tak datang Junlock?
Yes, doctor.
Why 0 over there? Why not 1, 2, 3, 4, 10, 100?
I don't know.
You don't know. Franklin?
Yes, doctor.
Why 0 over there? Why not 1, 2, 3, 10, 100?
Hmm, I don't know also, doctor.
Don't know. Yiling? Tak datang.
Yes, doctor.
Tak jawab saja. No respond, I assume.
Hello?
Then yeah, why 0? Why 0 in the command? Why not 1, 2, 10, 100?
Because the open loop pose is start from 0. I mean the
Sharon? Wrong answer. Why 0 there? Tak datang.
hello?
Why 0 there? Why not 1, 2, 10, 100? Why 0 in this command?
Default. Default 0.
Huh?
Because it's natural.
Natural?
I don't know.
Okay, one more. Hello?
Hello?
Tak tahu. Haikal? Why 0?
Uh, I don't know, doctor.
You don't know. Syafiq?
Because just now the damping ratio is at the coordinate 0.5 and 0 on the y-axis.
Alah.
Yeah.
Aina? Why 0? Why not 10? 100? Aina tak datang. Tak datang Viyin? Why 0?
Yes, doctor. Because there is zero pose.
Lama. Alif? Wrong answer. Why 0? Alif? Ikhwan?
Dia pergi tanda doktor.
Oyim?
Yes, doctor.
Why 0?
Because it is at origin.
Because 0 is origin. I already wrote my answer over here. Where are you? Example 10. Example 10, Sharul Naim. Read the question loudly.
Sketch the root locus for the system and find the following. The transfer function.
Sambung.
You mean that open loop pose open loop 0, doctor?
Tak, ni sambung.
The point and gain where the locus cross the 0.45 damping ratio line. The range of K within which the system is stable. Compare result using MATLAB.
Right. So this is the open loop transfer function. How many open loop zeros? Akmal Hakimi. How many open loop zeros?
Two, Doctor.
Value? Value. Two plus minus J4.
Plus minus J4.
Irfan Hakimi. How many open
Yes,
loop
Doctor.
holes? How many open loop holes?
Two.
Two. Value?
Wait.
Tak payah calculator.
-2, -4.
Tak payah calculator. Yang atas tu calculator. Okay. So damping ratio zeta 0.45. Theta is equal to Pak Izin. Pak Izin.
Yes.
Theta equal to
Beta equal to cos. Wait, no. Inverse cos 0.45.
that
Oh,
is that is
that is. Wait. Equals to 63.226. 63.26.
63.26 degrees. Okay.
Yes.
Okay. So this is the plot. This is the zeros. This is the poles. Okay. Dylan. Dylan. Tak datang. Najmi. Najmi.
Hello, Doctor.
How many root locus branch in the plot?
Two, Doctor.
Huh? Two. Why? Why?
Because two open loop poles.
Because two open loop poles.
Yes.
Okay.
Okay, thank you, Doctor.
Faham eh? Okay. Harish. Harish,
Yeah, Doctor.
estimate the breakaway point. Estimate.
0.55.
Astaghfirullahalazim. Budak itu debi kan. Tak faham. Munib. Absent. Amir Farhan. Tak datang. Danish. Muhammad Danish.
Yes, Doctor.
What is estimation of breakaway point from
Negative
locus?
2.9.
Negative 2.9 lebih kurang. Ni, tengok sini. Situ lebih kurang. So we plot as shown here. So this is theta. Theta equal to Q in theta. equal to datang. Shazwina, theta equal to
63.226.
okay, good. Okay, zeta 0.45, theta 63.26. So this is the angle of theta, and this one is the point intersection between damping ratio line and root locus. The name is dominant pole. What is the value over here? Qabil, what is the dominant pole's value over there?
Negative 1.53 plus J 3.303.
Okay. Okay, thank you. Okay, and this is the breakaway point. Okay, so the breakaway point is dia suka saja. Minus 2.85. Okay. So this is the way to calculate the gain K. I don't advise this. So I advise you to use the magnitude formula. So what is the formula for to calculate gain over there? Gun Willig. Rata. Apa?
Hello.
What is the gain K? The formula?
Substitute the S plus 2,
Magnitude.
S plus 4
Magnitude.
over S squared minus 4S plus 20.
Magnitude. Then replace.
Replace S equal negative 2.9 and with negative 1.53
Plus J.
J 3.03.
And the value is? The value is?
Around 0.4417.
Okay, good. Thank you. Then we plot there. So we got the same answer. Okay, verifications. Yi Fei Xiao. Yi Fei Xiao.
Yes, doctor.
What is the omega n value from the plot?
3.39
3.39 what?
radian per second.
Radian per second. What is the overshoot value over there?
20.5%.
Okay. So to validate this value, the J omega crossing, okay, with the root locus intersect with the imaginary axis, we use the Ralph-Lewis. Taking the open loop transfer function, then convert to closed loop transfer function, and take the denominator of the closed loop transfer function equal to 0. And this equation, we call it as Ng Yi Yang. This equation, we call it as
characteristic equation.
characteristic equation. Then after that, you use the characteristic equation, put inside the Ralph-Lewis table, okay? S square, S1, S0, okay? Then continue. You got this 8 plus 20K. Okay. So our concern now is this is first column, guys. First column of Ruthwis table must greater from 0 for stability. Okay. So we simplified. Okay, this one. Number 1. Number 2. And number 3. Okay. So range of stability is between 0 and 1.5. Okay. Harish, are you there? Harish,
Yes, yes.
what happened if K equal to 2.0
Unstable.
and stable? Yong? Yong,
Yes, Doctor.
what happened when K is equal to 1?
Stable.
Stable. Aina? 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 Tahu. Qabil? Qabil,
Ya, Doktor.
when K equal to 1.5, what happened?
Marginally, Doktor.
Apa dia
Marginally
marginal?
stable.
Marginal stable. Okay. So that's why we choose K equal to 1.5 because when root locus cross J omega axis, that is when the gain K is critical. So this is we call K critical. That's why we choose 1.5. Then we insert K inside the given equation 2.5 s squared plus 38 square root minus 15 plus minus J 3.9, guys. So this is S is equal to J omega equal to J 3.9. That's why omega is equal to 3.9 radian per second. So this is the verification using MATLAB. Then find the breakaway point by calculations. Okay, U divided by V. So we have 2 points. Okay. Ang Yi Yang,
Yes, Doctor.
which one we have to choose? Minus 2.85 or 5.25?
Minus 2.85.
Why? Justification?
Due the S is less than 0.
Because breakaway point lie on
left-hand side.
Left-hand side. Left half plane.
Left half plane.
Left half plane. Okay. Okay. Harish.
Yeah,
What is the gain value at the breakaway point?
0.024. -3, sorry.
Huh?
Gain value, Doctor.
Gain value. Dia punya breakaway point value is minus 2.88. Dia punya gain.
0.0248.
How you get that? How you get that? By calculation?
Right. Ah,
Cakap lah. Saya tulis ni.
um,
Magnitude.
magnitude, sorry.
Okay, lembab budak ni. Magnitude S plus 2, S plus 4 divide by magnitude.
S square minus 4S plus 20
So equal to?
equals to 0.0248.
Macam tu lah. Okay. So this is how to draw the zeta line 0.45. Yeah. Okay. Okay. 63.26 degrees. And then we have a break. Penat. Kita break sekejap. Can?
Boleh. Okay.
Ha?
Boleh.
Break sekejap 10 minit. Okay, we continue. Can you hear me?
Yes, okay.
Take your attendance, section 1 and section 2, as in the WhatsApp QR code. Farina Jaslin,
Yes, doctor.
can you read the question? Example 11.
Given a unity feedback system that has the forward transfer function Gs equals to K s minus 2 s minus 4 over s squared plus 6s plus 25. Do the following. A. Sketch the root locus. B. Find the imaginary axis crossing. C. Find the gain K at the J omega at axis crossing. D. Find the break-in point. E. Find the point where the locus crosses the 0.5 damping ratio line. F. Find the gain at the point where the locus F crosses the 0.5 damping ratio line. G. Find the range of gain K for which the system is stable.
Thank you. Right, sketch the root locus. This one is given plot. Okay, so this is the plot. Okay, so imaginary J omega axis crossing, which is here. Okay, where K critical occurred. Okay. So by observations, we found that the value is plus minus J 4.06. Okay. Okay. Then find the gain K. Find the gain K. Two way to calculate the gain K, either by using the Ruth Weiss, okay, as shown here. That is, find the open loop transfer function, closed loop transfer function, characteristic equation, Ruth Weiss table. Then you use this first column, okay? 1 plus K greater than 0, 6 minus 6K greater than 0, and 25 plus greater than 0. Okay, so also can, but I advise you directly, okay, using the formula of the magnitude, which is x squared 6s plus 25. Then s minus 2, s minus 4. Okay, so you replace with s is equal to plus j 4.06, insert inside. Okay, then you will get the value is about, the gain is about, where the gain? Can somebody calculate? What is the value? Somebody calculate, please. K equal to 1, okay, 1.0. Because from here, the range of stability is between 0 to k equal to 1. So k critical equal to 1. Okay. Right. So this is the point there, k equal to 1. Find the break-in point. So break-in point is somewhere here, break-in point. Break-in point, it occurred between two zeros. Okay. So the value of the break-in point, can you read from the root locus over there? Izzah Shamimi. Izzah Shamimi.
Yes, doctor.
Dengar agak kuat sikit suara.
Yes, doctor.
Break-in point.
2.89.
2.89. Positif,
Positive.
2.89, as Izzah said. And then Izzah, how you calculate the gain over there?
To calculate the gain, we use the formula.
Okay. What is the formula?
Magnitude.
Magnitude.
S squared plus 6s plus 25 over magnitude s minus 2 magnitude s minus 4.
Which is equal to?
1.
Side equal to?
51.3.
Thank you. 51.3, guys. Without pressing calculator, Izzah Shamimi successful. Calculate the gain key, 51.3. Brilliant. Okay. And at this break-in point, okay, the damping ratio is equal to 1. Meaning that zeta equal to 1. Shabik Kashfi.
Yes, doctor.
Zeta equal 1 is critical what? Critical damp, undamp. Critical damp. Okay.
Critical damp.
That's critical damp. Everybody repeat critical damp.
Critical damp.
Critical damp.
Okay, I would like to remind you, Student always confuse critical dam where zeta equal to 1 is not equal with critical gain. Okay, please remember this. Student always make mistake. Critical dam zeta equal to 1 is not equal to critical gain, K critical. Can you repeat after me? Critical dam zeta equal to 1 not equal to critical gain, K critical. Repeat.
Critical
Critical
dam
dam
zeta
zeta
equal
equal
to
to 1
1
not
not
equal
equal to
to
critical
critical gain
gain
K.
Okay. Then 0.5. Without pressing calculator, what is the angle when zeta equal to 0.5? Muhammad Alif, F1.
60
Alif F1. 60
degree.
60 degrees, eh? So 60 degrees, somewhere here lah. Okay. Theta 60 degrees. Okay. So you get the dominant pole. Okay. What is the value of the dominant pole over there? Irfan Hakimi. Irfan Hakimi.
Dominant pole.
Tengok slide tu, tengok.
Negative negative 1.5.
Oi, tengok ni.
Negative 2.42 plus 4.18 G.
J 4.18 bukan 4.18 J. J tu dulu. Ulang.
Negative 2.42 plus G 4.18.
Okay, thank you. Then we have tutorials. Okay. Tutorial 1, question 1. Sharul Naim. Read the question.
Consider a control system with a forward transfer function from the locus, plot the rules of RL and determine the value of K so that the damping ratio is approximately
0.5. Kita 60 darjah. Okay. So what do you mean by HS equal to 1? Akmal Hakim.
Unity.
Unity apa?
There is any unity feedback.
Feedback.
Unity feedback. Okay. Okay. Lebih kurang soalan dia macam itu. More or less. Okay. So this is your 0 minus 1. Okay. Kat sini J omega crossing. Kat sini breakaway point. Okay. So 60 degrees is over here. Okay. So 3 open loopholes, 0 minus 1 minus 2, which give you 3 root locus branch. No open loop zeros. Okay. Characteristic equation is cubic. So there are 3 locus path. Okay. No zeros. All locus will move to infinity. Okay. Ended at infinity. Ended at infinity. Ended at infinity. Can. All 3 poles are real parts of the negative axis. Okay, so this is the characteristic equations. So the angle of asymptotes is 60 degrees, minus 180 and 300. Okay. Then the intersections is 0, minus 1, minus 2, divided by 3, open loop poles, which is minus 1. Okay. So it is located over there, if I can write it. So okay, 60 degrees, 180, and 300. Okay. Dan dia punya ni adalah asymptote cross with the real axis. Okay. Breakaway point by calculus. So you just what do you call it? Differentiation. And you will get minus 0.423, which is over here. Minus 0.423. We choose this one instead of minus 1.577. And from there, we can calculate the K value, okay, either by using the formula of magnitude or using the Roof-Lewis table. If you look here, okay, first column of Roof-Lewis table, this one is greater than 0, greater than 0. This one greater than 0, greater than 0, greater than 0. So you simplify. Over 3 greater than 0. Okay. 6 minus K greater than 0. Minus K minus 6. Then K less than 6. So K critical is K equal to 6. Okay. Which will give you, when you insert inside the even equations, okay, you replace this one with 6. Simplified. Then you will get plus minus J 1.4142. And what is the frequency value? Oscillation frequency. Haikal Hakimi. Tak datang. Ammar, Muhammad Ammar.
Yes, Doctor.
What is the oscillation frequency?
1.4142.
Huh?
1.4142.
Ringgit Malaysia. Dollar.
Pak radian per second.
Radian per second. Okay. Then you compare this one. This one is plus minus J. Okay. So omega is 1.4142. Right. So this is the dominant pole. And the value of gain K there 1.07. This one is K critical. And this one is the breaking point. Okay. And the value over here is zeta equal to 1, damping ratio at breakaway point. What is the damping ratio over here when K equal to 6? Shazwina? Shazwina?
Yes, Doctor.
At the J omega crossing, the gain K is 6. Okay. The value is minus 1.414 plus J 1.1414. What is the zeta value over here? J omega cosine. The value of zeta. Tak tahu. Tak tahu Mazin Ahmad. Mazin Ahmad. Ibsen. Yi Fei Xiao. Yi Fei Xiao.
Yes, doctor.
What is the value of zeta at k equal to 6?
6.
Ni,
0.
0, betul. 0 And the zeta value at breakaway point is 1. So therefore, the green area here, okay, we call it as underdam region. Repeat. Underdam region. Repeat. Underdam region. Repeat.
Underdam region.
Underdam region.
Under the region.
So the underdam region, the zeta range is between
0 and 1.
0 and 1.
0 and 1.
Please remember this. Very, 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 very important. Iza Shamimi.
Yes, doctor.
The green area, we call it as?
Underdam region.
What is the zeta range value for underdam region?
0 to 1.
0 to 1. So we design the controller in the green area, which is underdam region. Do you understand or not? Hello guys, do you understand or not?
Yes.
Tak dengar. Understand or not?
Yes.
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 Online sedap je boleh baring-baring kan. Boleh makan, siap kau. Balik nanti minggu depan, siap. So gain damping ratio at 0.5 using the magnitude formula. As I teach you, okay, then we get the value is 1.07 at the dominant pole. Okay, this one is K at dominant poles. What is the third pole? At K 1.07, so we take K 1.07, we insert inside here, which is the characteristic equation. Okay. So K ni we replace with 1.07. Okay, so we get this cubic equation. Repeat. Cubic equation.
Big equation.
We want to find the third pole at K equal to 1.07. So when you press calculator, okay, when you press calculator, what is the roots that you will get? Press calculator now.
Negative 2.34
And
negative 0.33
plus minus J.
plus minus J 0.6.
0.58. Okay, so the pairing, the complex conjugate pole minus 0.33 plus minus J 0.58 is the dominant pole. Okay, so the remaining pole, which is minus 2.34, that is your third pole. Repeat, third pole. Third pole.
Third pole.
That is how you calculate the third pole.
Third pole.
It is located over here. Third pole. Dominant pole over here. Pairing, complex conjugate pole. And the third pole is minus 2.34. Okay? Okay or not?
Okay.
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 Kalau okay, gun wheel Gun wheel
Hello. Yes.
Gun wheel
Hello.
Read the question.
Consider the control system with a forward transfer function GS equal K S plus 2 over S squared plus 2S plus 3 with unity feedback. So based on the root locus plot, prove all the root locus rules and determine the approximate damping ratio for a value of K equal 1.33.
Okay. Okay, you have to find the damping ratio value. Macam mana tu? How to do it? So this is the plot. Okay, 0, minus 2. And this one is, can somebody help me? S square plus 2S plus 3. What is the roots? Help me, please.
-1.
-1.
Plus minus J set 2.
Set 2. Set 2 tu berapa?
1.414.
414.
Yes.
Okay.
4142.
Okay, which is here, Sini kan?
Yes, doctor.
Nampak tak? Nampak So, dia kata model given GS, open loop, unity feedback, plot rule locus given. So, determine the approximate damping ratio for a value of K 1.33. Macam mana tu? Macam mana nak buat? Pakai apa? Macam mana nak buat? So, we find the characteristic equation dulu. Okay. Then, characteristic equation. Oops. S square okay. Characteristic equation from open loop transfer function can is S square plus 2K plus S.
Yes.
Can?
Yes, doctor.
Okay. Well,
Plus 3 plus 2K.
3 plus 2K.
Yes, are equal to 0.
Okay. Given K equal to K equal to 1.33. Can? Hello?
Yes, doctor. 1.33.
2 plus 1.33, 3.33S, correct? Hello?
Yes, Doctor.
Tidur. Ni macam mana? 3 plus 2K.
5.66.
3 plus 2.66, correct?
Yes.
3.33s plus 5.66 equal to 0. So this is quadratic equation. Repeat.
Quadratic equation.
Quadratic
Quadratic
equation.
equation.
Roots dia apa? Roots. Help me
Negative.
find the roots.
Negative 1.665 plus minus 1.69 ij 1.699.
699. Okay. Kita ringkaskan 1.7 boleh tak? Susah nak cari kan? Betul tak?
Boleh.
Tujuh?
Tujuh.
Jadi, if the roots, ini apa saya tulis ni? Roots are minus 1.7 plus minus j 1.7, correct?
Yes.
We call it as dominant pole, correct? Correct or not?
Yes, Doctor.
Hai. Real part is equal to imaginary part.
Imaginary number. Imaginary.
Iza Shamimi?
Yes,
Kalau
Doctor.
if real part equal to imaginary part, meaning?
Dominant pole.
Meaning? Bagus soalan ni. Saya suka soalan ni. Bagus untuk ujian. If real part equal to imaginary part, meaning?
Zero.
Oh, kat mana ni? Bunyi angin kuat betul lah. Theta equal to?
Zero.
No. Alif. Oh, Alif.
Tandas, Doctor.
Oh, so kita tandas je. Aina? Aina. If real part equal to imaginary part, meaning that the theta is?
45 degree.
Bagus. 45 degrees. Okay. 45 degrees. Kan?
Why, Doctor? Why?
Why? Why 45 degrees? Who said that? Who said that? Because
Cuba plot.
theta 45 degrees will give you zeta 0.707. Correct or not? Cos 45 degrees. Hello?
Yes, Doctor.
Kan?
Doktor,
Jadi,
ke sebab
Sekejap, orang tengah lukis ni. So, this is your origin, am I right? So, you take the minus 1.7 and 1.7 over here. Okay. Roughly over here, roughly. Okay. So that is zeta 0.707, which will give you the angle theta, which is 45 degrees. Any question? Any question?
InsyaAllah no, Doctor.
Huh?
No.
Huh? Hello?
Ya, Doctor.
Understand?
Tak ada. Yes.
Understand. Okay. So this is very good question. The question asks you, first is, I repeat, this one. Characteristic equation from the open loop transfer function is given. Okay. From there, we find the closed loop transfer function, and then we find the characteristic equation. This is characteristic equation. given 1.33. Insert K here, then you get S square plus 3.33S plus 5.66 equal to 0. So it is a quadratic equation, characteristic equation. And the roots is minus 1.7 plus minus J 1.7. I simplify because this is a 3 decimal point, more or less the same. Okay. So this is the roots, which is the real part and imaginary part is the same. And it is a dominant pole. So as Aina told us just now, the real part, which is minus 1.7, equal to the imaginary part, which is also 1.7. Guys? Okay?
Yes.
So when the real part equal to imaginary part, so the angle is 45 degrees. If you don't trust me, okay? If you don't trust me, tangent theta is equal to 1.7 divide 1.7. Theta equal to
45 degree.
theta equal to
45.
45 degrees.
imaginary part and is the same.
Oh.
Ni nak kena berfikir. This is what kemahiran berfikir aras tinggi. High level thinking question. Okay, 1.7 guys. Theta is here. Dominant pole is here. And the rest is the same lah. They repeat the angle, break-in point, was already there. Okay? Can? Negative 1.7 plus J 1 point plus minus. Cos theta 0.707 actually. Okay. So theta is 45 degrees. Okay. So this is the dominant pole. So the rest tutorial you do it yourself. Okay. I discussed already Q1 and Q2 and the rest is about the same. Okay. Because we are limited of time. Okay. Until Q12. Next week, Thursday, we will go to chapter 2. Is it okay?
Okay, doctor.
Okay.
The rest is you just tutorial. You have to test lah. Do it yourself. Then you show to me. If you done, you PM me. Direct message to me. From question number 3 and onwards. Okay, Q3 onwards. Okay. And then if you don't understand, you can join the Brian Douglas YouTube channel as well as my channel. Okay. As shown here on the root locus. Any question? Attendance? Done?
Done, doctor.
Any question? Irfan Hakimi? Any question?
No question.
Check. Apa ni? English, natural frequency. Natural frequency is omega n. Natural frequency is omega n. Undamped natural frequency in radian per second. The length between the origin towards the dominant pole. The length will give you omega n. Or you can find it in the circle line of the grid of root locus. The circle line represents omega n of the grid root locus. If the straight line is the damping ratio line, the circle line is the omega n line. So with that, I ended my lecture today. Sorry to take your time. You have another class on 12, isn't it? You have class on 12? Hello, you have class on 12?
Yes.
Okay.
No,
so-
doctor.
No, doctor. Okay. I will share you the video of YouTube later. Okay. Thank you very much. Bye-bye.
Thank you,
Thank you,
Doctor.
Thank you, Doctor.
Doctor.
Thank you, Doctor.
Doctor.
Dah habis, dah habis.
Thank you, Doctor.
Habis. Dah habis.